Welcome to Homework Lib.
We're going to have a pipe that has the following frequencies corresponding to 60 Hz, 100 Hz, and 140 Hz. And we want to determine if this is an open or a closed system. So for an open system, what is going to happen is that, let me put it without the circle over here to not confuse it with the closed one. What is going to happen with the pressure as a function of the longitude of the pipe is that we're going to have in the fundamental the following curve. And for the first harmonic, or for n equal 2, we're going to have a curve like this. Of course, we need to draw also the complements of them because both of them are possible. But what we see is that the fundamental wavelength for an open system is equal to 2 times L. And for lambda 2, it's going to be equal to L directly. And we can go and continue, and we can say that lambda for the n harmonic is going to be equal to 2L divided by n. Thus, the frequency for the n harmonic is going to be equal to the velocity of sound divided by the wavelength that we have. So we're going to get n times velocity of sound divided by 2L, which is n times the fundamental harmonic. Now, if we compare this to a one closed end, what we're going to get is that now the graph of the pressure is going to have the following shape. The fundamental goes like this, and the first harmonic, since we are restricted to having a value of zero pressure in the open end, the wavelength is going to change. So for lambda 2 and for lambda 1, we're going to get 4 times L directly. And in the case for lambda 2, the value is going to be 4L divided by 3. So in this case, we cannot say that we have even harmonics. The value for lambda would be lambda 3. So m can be only odd in the open system, and the frequency is going to be equal to velocity of sound divided by lambda n, which is going to be n times velocity of sound divided by 4 times L. But n can only be odd. This is the very important fact that we need to take into account when we are dealing with a one closed end. Again, this is equal to n times the fundamental frequency, right? So if we want to look at the difference of frequencies in each of the systems, we are going to do the operation of fn plus 1 minus f of n. This is going to be equal to change of frequency between two consecutive ones. In this case, we're going to get n plus 1 times the fundamental minus n times the fundamental. The change of frequency in the open system is equal to the fundamental frequency. Now, if we do the same thing for the closed system, we need to take f of n plus 2 to keep an odd value minus f of n. So this is going to become n plus 2 times the fundamental minus n times the fundamental. And the value for change of frequency corresponds to 2 times the fundamental frequency. Now with this information, we can compare our results. We have 60 Hz, 100 Hz, 100 Hz, and 140 Hz. Notice that the difference is equal to 40 Hz. Let's analyze first if it was an open system. If this was open, this would mean that the fundamental is equal to 40 Hz. Thus, the first harmonic would correspond to 80 Hz. With this, we can already say that this is not the correct option for us, because we cannot satisfy this condition for delta f. On the other hand, if we have a closed one, put in black, well, one side is closed, the other one is going to be open, but just to verify it, delta f corresponds to 2 times the fundamental. Thus, the value for the fundamental would be equal to 20 hertz. If that is true, f1 is equal to 20 hertz, f2 would be equal to 60 hertz, because we're going to add 2 times the fundamental frequency. F3 would be 100 hertz, and F4 would be 140 hertz. So with this, we have identified our system. It is a closed system, and the corresponding frequencies correspond to the second, third, and fourth harmonics that we have. So that would be all. Thank you very much, and have a good one.